If you have two parts that move past each other, you need a bearing. And they could be sliding past each other, or often they're rotating relative to each other, like a shaft in a gear. There are different types of bearings. There are what we call bushings. Technically, they're called plain bearings, but everybody calls them bushings. And they don't have any rollers or balls. They don't have moving parts. They're just solid material. Some people call them a journal bearing, and a journal is just the place on the shaft that's supported by the bearing. And so the journal bearing is this bushing that supports the journal. Here's a drawing. They take up less space than roller bearings, so that's a good thing, and they cost less. If you took the mechanical design class in fall, you figured out some clearances for a bushing that pressed into a hub for some kind of caster assembly. Bushings might be made out of nylon, they might be made out of bronze, there are a few other materials. You sometimes see them made out of UHMW, ultra high molecular weight plastic. Nylon and bronze are the most common, and you can buy those that are oil filled, so the oil is built right into the material. Then what we call bearings are technically anti-friction bearings, but we just call them bearings. They have things that move: ball bearings, roller bearings, needle bearings. And you can get bearings that support a load in a couple of different directions. If the load comes straight down along the radius of a circle, straight down towards the shaft, that's a radial load, and you want a radial bearing. If you have a load that goes parallel with the shaft, then you need a thrust bearing. And if you compare these two pictures, the lower left and the middle left, you can see the difference in the arrangement between a radial bearing and a thrust bearing. So you need to know which direction you're supporting a load before you order a bearing. Here's a diagram showing radial loads and lengthwise thrust loads. Radial bearings are where you have something that rotates, and examples include spur gears, the gears we did at the start of the term, shivs for belt drives, sprockets for chain drives, those sorts of parallel things. If you have gears that give you some sideways push, like for example, here's a worm set, a worm and a worm gear, that gives a sideways push, and in that assembly you're going to need a thrust bearing. Then you can decide, okay, what type of rolling element do you want? A ball bearing has, as the name implies, spherical balls in here. These are good for high speeds. They're less good for heavy loads, so this is why you often see them in smaller situations. You don't see them in big heavy situations. In a ball bearing, the inside and outside round thing that holds the balls is called a race. There's an inner race and an outer race. And then this thing in here that captures each ball is called a cage. Outer race, inner race, though. I stuck in a page out of Scientific American. I thought you might be interested. It just illustrates how ball bearings are made. And ballpoint pens. So ball bearings come in various configurations. You can get single and double row, and you can get radial and thrust and so forth. So let me back up. So ball bearings have tangency at a single point. They have a single point contact, which is why they don't carry heavy loads. A roller bearing has line contact, so there's a line of contact all the way along the roller, which is why they carry heavier loads. And you can get rollers in different shapes. When we say roller bearing, often we mean this plain, straight cylindrical roller. Looks like this. So there's a roller bearing, and you can see it supports heavy loads. Here's a nice illustration of the races, the inner and outer race. If you have a situation where the shafts tend to be misaligned, you might want to go with a more expensive kind of bearing called a spherical roller bearing. And if you look at a drawing that is a section through a spherical roller bearing, you see that these rollers are actually a slice cut out of a sphere. And here you can see a three-dimensional illustration, a slice cut out of a sphere. So these bearings can rotate in compound directions and keep the shafts working. Then another shape of roller is the tapered roller bearing. So it has line contact like a plain roller bearing, but it's tapered, and it can take thrust loads. In a taper roller bearing, the races are called a cup and a cone for some reason. Don't ask me why. Examples. Then needle bearings have really small diameter rollers and a whole bunch of them. They take up less space than cylindrical roller bearings because these needles are so small. And they carry a lot of load because they have a lot of line contact surfaces carrying the load. At the start of the term, when we started talking about, well, it wasn't the start, was it? It was the middle of the term. We started talking about cams and cam followers, and we mentioned that cam followers were just rollers with needle bearings in them. Well, here they are, rollers with needle bearings in them. Finally, last slide, what do you do if you have to draw a bearing? The illustration on the bottom is from our book, and he's showing us what to do if your boss asks for a schematic representation. And here you can think of when you thought about drawing screw threads, and you saw that, well, you could draw a detailed view of a thread, actually drawing the thread. You could draw a schematic representation, which is kind of like a thread, but not really. Or you could draw a simplified representation of a thread, which was hidden lines. In bearings, it's a similar situation. I don't have a picture of a detailed drawing because we've been looking at them throughout this slideshow. But here, at the bottom of the slide, are schematic symbols for various kinds of bearings. You might choose to use those. You can see they don't take very long to draw. But you can also choose to do just a simplified representation where the roller or ball would be, you just draw an X, box with an X. Simplified, that's how you draw a simplified bearing. Everybody knows what that represents once you give them a bill of material, and it's really fast to draw.